We are Teammate, and this is our technical presentation. Bakersfield Predictors is a website designed with home buyers and sellers in mind. It offers users two main tools, Predict My Price and Grade My Offer, and is based on a predictive machine learning model that estimates home sale prices in Bakersfield, California, based on key features of the home. The Predict My Price tool outputs a fair home offer price to users, while the Grade My Offer tool compares a given home offer to the value of the home for an easy-to-understand grid.
We first began the project by researching where we could acquire housing data and what data we needed. We chose the house attributes based on what parameters homeowners and buyers would readily know, as well as what were important determining factors in the price of a home. We found an API that collected all the data that we were looking for and created an R script to call it multiple times to collect all listings. We then wrote a data cleaning function in R to get rid of NA values produced by the API, as well as unrealistic values for our home attributes, such as having 0 beds or baths. Additionally, we wrote our own data scraping script to scrape a website to gather data on median incomes by zip code in Bakersfield. We used R to connect to our SQL account and inserted the data into our database.
For our predictive model, we decided on using a boosting model utilizing the Generalized Boosting Regression Models, or GBM, package in R. We chose this because it was available on the Purdue servers, interpretable through explanation, and accurate for our level of complexity. In the process of fitting the boosting model, we optimized the shrinkage, interaction depth, and number of trees parameters through using R's predict function, computing the results, and minimizing the mean squared error using the validation set approach for various training and testing partitions, as is industry practice with boosting regression problems. During this process, we also removed predictors that did not improve the accuracy of the model, such as new construction and crime rating. This simplified the website input fields while also reducing the model's bias. After several iterations of training, validation, and testing, we saved the best model using R's Save RDS functionality. This saved model will be used later to take inputs from the website through PHP and run various R scripts that again utilize the built-in predict function.
We started off by creating a user login page which consisted of a login form and a hidden form to create an account for the users, after which we proceeded to create a PHP script that connected the website's front end and our SQL database so as to enter the user information into a users table inside the database. The next step was to make sure that the passwords that are entered by the users are hashed and sorted through the MD5 password encryption function inside PHP. Then we added multiple error handlers to the code to make sure that the users entered valid and unique emails, unique usernames, and appropriate passwords with enough complexity. We did this by requiring the users to enter passwords that are 10 plus characters, alphanumeric, include a special character, and have an uppercase letter. We then created a login script that included an SQL query that would check the database for the username and the password and would lock the user in to the website and save their username in session variables that were then passed to other pages in the website so that each page in the website can recognize the user that has logged in. Finally, we tested the sign up and the login pages of our website by making test cases that were intended to create faulty users into the website and see if the website displayed the correct error messages with each faulty input we tried to run through the system. Like for example, using an invalid email or using an existing username to create an account on the website. We also focused on increasing user security by using functions like MySQLi real escape string to prevent SQL injection attacks on the website.
The database we created contains two distinct portions that do not interact. On the left, we have the house and zip codes tables. The house table holds all of the training and testing data for individual sold homes located in Bakersfield. House ID was a variable that we created that auto-increments for each entry, designated as the primary key instead of using that house address in case any given home in Bakersfield was bought and sold on multiple different occasions. On the right, we have the user's data. Users table was created to store the user's information. We chose the user's UID, which is the username, as the primary key because the website was designed that each user must have a unique username to create an account. In the predictions table, which comes from the Predict My Price tool, each unique combination is identified by the primary key prediction ID, which auto-increments as entries are made. These are linked to the specific user that made them with the foreign key user's UID to keep track of which predictions were made by which user. The probability of two people making the same prediction is incredibly low because of all of the possible permutations and combinations of house attributes. The graded table comes from the Grade My Offer tool and is similar to the predictions table with the addition of a couple attributes. Because the graded calculations require more computation and data stored than the predictions, we decided to have the data stored in separate tables despite many of their similarities.
After a user logs in, the session starts for that particular user, and their username is stored in PHP as a variable which is used to query SQL. After querying SQL, the website is able to display each past predictions on the profile page. It is done very similarly with their previously graded offers. We display all of these predictions and graded offers for the user to reference back when making their next housing decision.
In order to create a unique experience for each user, all input fields are left entirely flexible, with HTML being used to limit each field to positive integer values. This prevents the user from entering any infeasible values such as characters or negative numbers to the machine learning model. The user's valid inputs are then passed to R through PHP, where the built-in predict function is used in conjunction with the save boosting model in order to develop an accurate prediction. This predicted value is then outputted to the user along with other information as necessary. When using the Grade My Offer tool, the user will also receive a message on how their offer compares to the predicted price from our model. This grading analysis is performed behind the scenes through computing various ranges for plus or minus 1, 2, or 3 error deviations from the predicted price. In addition, to better the user's understanding of this relationship, these ranges are also visualized through a gauge that is displayed with appropriate red, yellow, and green sections, as well as an indicator denoting the user's inputted offer amongst those sections. On top of this, in order to convey the importance of house size and better visualize Bakersfield for our users, a histogram was generated. This histogram is generated through an initial SQL query to our database that gathers the home size of all of our records. This is done every time the page is loaded in order to provide as much clear and accurate information as possible. Once the house size data has been gathered from SQL, it is parsed in PHP and sent to JavaScript, where it is utilized with Plotly's JavaScript histogram functionality. The user's input for house size is also plotted in red on top of the appropriate bin. The decision to make this histogram specific to house size was due to how house size ended up being the most influential factor for our model's prediction of home price. The histogram is additionally fully interactive with several features such as zooming, selection, and even saving the histogram as a PNG file to your local computer. This histogram illustrates how realistic the user's inputted home size will be when compared to other houses that have been documented and sold in Bakersfield.
We recognized that it was important to test all possible user inputs that could be entered on the website to ensure that proper results, warnings, and errors were displayed. We went about this by creating a test script by copying the PHP code for both the Grade My Offer page and the Predict My Price page, and then converting it into functions that would display all the test case results into a very primitive version of our website. We felt this was the best way to go about testing the user's inputs because the function code was identical to the website, and we would have all the test cases displayed in one place. Tests were done using selected inputs that would be barely outside the model bounds, inside the model bounds, boundary cases, and cases that exceeded the model bounds. We made sure that the tests covered all the cases which would cause errors, display warnings, and display gauge results. We did not run tests for user inputs that included negative numbers or characters because we restricted the input fields using HTML field set. The model would not run once these fields were inputted and could not be computed in the PHP code.